Right, so the one really unique thing you're looking at today has to do with the effect graphically that occurs when you multiply or add or make a change to function form. So the thing that gets confusing is the function form, and I don't really know how to fix that one for you on this case. But the key is really to focus on the graph and how the numbers that are added or say changed in the equation affect the outcome and how they relate to our general form. So let me remind you, the general form for all absolute value equations was y equals some number a times x minus h plus k, where a had to do with whether the absolute value opened up or down, or the function opened up or down, whether it was stretched vertically or whether it was compressed vertically. H had to do with the horizontal shift of the entire graph, and K had to do with the vertical shift of the entire graph. So with that stuff in mind, here's an example. We've got y equals 2 times f of x, and here on the right is the graph of f of x. Now, basically what you're trying to do in a problem like this is sketch the new graph, right? If this is f of x, the graph that you can see right here, what is the new graph if you're basically doubling this old graph? And you really have to pay attention to, is the 2 a, is it h, or is it k? And in this case, the 2 is playing the role of a, which means it affects the graph in terms of whether it's being stretched, compressed, and reflected. Now, since the 2 is positive, it's not being reflected across the x-axis. And since it's bigger than 1, that means it's stretching the whole thing out. It's making it taller. So what's happening is my y values, 0 and 3 and 3, are all being doubled. So doubling 0 doesn't really do anything. Doubling 3 changes this point to 2, 6. And doubling this 3 over here changes this point to 5, 6. So what this 2 times f of x does graphically is it stretches the whole thing vertically, so that it now looks something like that. And that's the effect graphically on doubling the original function f of x. And that's how a works in the process. Now here's a different situation. We're still starting from the same original graph, the same original function, whose graph goes through the points 0, 0, 2, 3, and 5, 3. So our original function is still the same. But now how it's being affected is different. And so we've got y equals negative f of x plus 2 plus 1. Now the negative has to do with a, right? It's being multiplied by the entire function. In this case, a is negative 1. The 2, the plus 2, has to do with h, right? In this case, h is negative 2, because, remember, the form is x minus whatever h is. And the 1 has to do with k. In this case, k is 1. Now, because a is negative, that means we've got a reflection across the x-axis, where it's going down, and all the y values are going to be multiplied by 1. So that's really not going to change anything. So or all the y values are going to be multiplied by negative 1 is another way to do it. On top of that, we've got a horizontal shift of 2 to the left and a vertical shift of 1 up. So we'll do this step by step. So first, if we start with my points 0, 0, and 2, 3, and 5, 3. So let's deal with A first. A is causing a reflection across the x-axis, so all the y values are becoming opposite sign. So with A, they become 0, 0, 2, negative 3, and 5, negative 3. Now we have to deal with H, which is a horizontal shift of 2 to the left, which means the x values are moving left too. So 0, 0 becomes negative 2, 0. 2, negative 3 becomes 0, negative 3. And 5, negative 3 becomes 3, negative 3. Finally, we have to deal with k, which is a vertical shift up 1, which means all the y values are increasing by 1. So we'll have negative 2, 1, 0, negative 2, and 3, negative 2. That's how my points have been changed. So if I plot these points, I'll do the best I can to kind of cram things in here. Then I'll just do a new graph. So I'll just do a new graph to make it easier. So I've got negative 2, 1. Oops, negative 2, 1, 0, negative 2, and 3, negative 2. And so now, because of all the changes that this graph has undergone, it has been reflected and then moved back 2 and up 1. And now it's ended up here. Hope this helps.